recording this. The phone died first time I tried, so now we're going to the computer. This is a question on reciprocal form when it's not in reciprocal form or not in vertex form, kind of going back and forth between these fractions with the whole numbers and without the whole numbers. And once you get the hang of it, it's actually pretty easy, quite easy. This star typically means the question's like a little bit harder, and we can go through this question in like 3-4 minutes. It's really not all that difficult, especially all these points that we're getting. Like, this can be very doable. A says our function wants to be in the not vertex form, because this is looking like a vertex form, up 4, left 3, vertical stretch. So let's take this, f of x equals 4 plus 5 over x plus 3. I'm going to think about this 4, and basically I just want to add fractions together. So I'm just going to make this 4 into 4 times x plus 3 over x plus 3. Just do some common denominator math. Real easy, not too bad at all. Distribute this, 4x plus 12 plus 5 plus 3. And now when you combine 4x plus 17 over x plus 3. Sweet. There's f of x in that form. Does it tell me to write a and b? No. So we're all good. B, express the function that in vertex form. Okay, sure. That's pretty easy. I'll rewrite it here for you. G of x is equal to x plus 10 over x plus 3. I'm trying to think about the denominator. Think about all these x's in the numerator and make sets, little binomial sets that are either double the bottom or triple the bottom or quadruple the bottom. That way they'll cancel out and give me a nice whole number. So when I see this x, it has to match with an x plus 3. So I'm going to rewrite this as x plus 3 plus 7 over x plus 3. If this 7 is confusing you, remember, x plus 10 has to be the value in the numerator. We cannot change that into something else just for fun. We have to balance it. So even though I want to reorganize as an x plus 3, this 7 keeps the balance with the 10. Now that looks pretty nice. Now I can't cross it off yet because the 7 and the x plus 3, all of this stuff is divided here. So I'm going to kind of spread it out into 2 bits. The 7 is still here. X plus 3 plus 7 divided separately. And now that they're separate, that can be crossed out. Now remember, anything divided by itself is not 0. It is a 1. So we have 1 plus 7 over x plus 3. And that is going to be g of x into vertex form. And lastly, we have C, or I guess it's not lastly. C is more or less the same thing. Okay, nice. I mean, these are free points. We love these. Same exact thing. I'm just going to think about the bottom, x plus 3, and I want to get this into vertex form. So same thing. I want to think about the numerator in stacks of x plus 3. Now, it's starting off with a 2x. That means I need to have 2 of these groups. And if I need x plus 3s, I'm going to need 2 x plus 3s. So I'm going to need plus 6. That way I have, double, a perfect double. Then I want to think about this number, which is going to be whatever number keeps the same. So it's 10, 6, so this needs to be 4. And then we can do this whole process pretty quick. 2 x plus 3 over x plus 3. That was GCF factoring of this part just to make it easier for you. Hopefully that didn't lose you. X plus 3, x plus 3. Now that we did a double pair, instead of leaving behind a 1, we're going to leave behind a 2. 2 plus 4 over x plus 3. That's h of x. Now D is asking us for the vertical asymptote and the horizontal asymptote. The vertical asymptote is the bottom equal to 0 or the denominator equal to 0. And the good news is bottom equals 0, 3, 3, 3. So Yeah, they're all looking like the same. I need to choose x equals -3 for all of these. The horizontal asymptote is going to be talking about my nice horizontal asymptote. There's a couple different ways that you can think about this. One way you can think about it is that the horizontal asymptote typically, the reciprocal graph typically has a horizontal asymptote at 0. And now that we've rearranged this +4 is a 4. So we should have y equals 4. And so we can do that with all these. This one was 1, and this last one was 2. Now the other way you can do it is by understanding how the horizontal asymptote of any rational function works. And that is that you compare the leading coefficients of the numerator and denominator. So instead of getting it in vertex form, if I think about it in this form, the not vertex form, if I think about this 4 and this 1 that is in front of the x, 4 divided by 1 is 4. If I take the kind of uglier form and I take the leading coefficient, 1 divided by 1 is 1, check. And for the last one, if I take kind of the ugly form, leading coefficient, 2 and 1 is 2. So there's two different ways you can do the horizontal asymptote. One using transformations, one using your knowledge of rational functions. Easy points. We take these all day.